In today's lecture, let's go over section 2.6. Question 1, let's graph f of x equals x squared and determine what is the domain. For these questions, I like to make a table. I want to figure out what x I'm going to use, and I'm just going to pick randomly -2, -1, 0, 1, and 2. And on the right side, let's figure out what x squared is. We have -2 squared, that's positive 4, -1 squared is positive 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So now we have a general idea of what this graph looks like. We can plot -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So this graph looks like a parabola. This is a parabola facing up, and the domain is how far left the graph goes to how far right it goes. It goes to -infinity to the left and to infinity to the right. This is the domain of our graph. In question 2, we want to graph x cubed and determine what the range is. We'll again make a table. Let's pick our x's as -2, -1, 0, 1, and 2 again. And we'll pick x cubes. On the right, we'll have x cubes. -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. This graph will look slightly different. We're going to have an S-shaped graph. We have -2, 8, -1, 1, 0, 0, 1, 1, and 2, 8. And so we have an S-shaped graph. The range is how far down the graph goes to how far up. We have it goes down to -infinity and it goes up forever. This is the range for a cubic function, -infinity to infinity. For question 3, let's graph the greatest integer function. What is the function value when x is equal to 1.1? F of 1.1 equals the greatest integer of 1.1 or less. Now this means we have to look at the integer that is the greatest equal to this or less. The greatest integer function is equal to the number inside or less. The closest integer that I have is 1. 1 is equal to this or less, and it's an integer. So the greatest integer of 1.1 is 1. Now to graph this function, we'll make a table. And I'm going to start with 0. Let's plot that. It's an easy value to use. At 0, the greatest integer of x at that value is 0. Now let's try 0.5. The greatest integer that's equal to this or less is still 0. And if I go up to 1, it's going to be 1. So at 1, it's actually going to be at 1. But anything between it, it's going to be 0. So from 0 up to 1, but not including 1, it's going to be 0 as the greatest integer. As soon as we get to 1, 1.9, that's still going to be 1. A greatest integer that's equal to 1.9 or less is still 1. But then when I reach 2, it jumps to 2. So this is going to be 1 up to 2, and then it jumps to 2. So we have a staircase pattern. Again, the greatest integer function is the integer that's equal to this or less. And then that means at 3, I'm going to have another jump. It's going to jump to 3. But it's going to have an open circle here again. So we have a staircase pattern. Now let's plug in some more values to get a good idea of what this looks like. Let's try negative 0.5. What's the integer that's equal to this or less? The closest integer that's equal to negative 0.5 or less is actually negative 1. We could try some more values. Negative 1.1. The greatest integer that's equal to this is actually negative 2. So now if we plot the graph, we have something that looks like this. It's a staircase pattern again. It's still continuing down in this fashion. So this is our graph of the greatest integer function. Question 4, let's graph the square root of x and determine what the domain is. Let's make a table again. Now the issue is we cannot pick negatives. The negatives do not work because we're taking the square root of it, and that's not possible to graph an imaginary number. So we'll take positive numbers. We'll start with 0 first. What's the square root of 0? The square root of 0 is 0. The square root of 1 is 1. Now I'm going to skip. I don't know what the square root of 2 is. I don't know what the square root of 3 is, but I do know the square root of 4. That's equivalent to 2. So I'm picking values of x that are easy to take the square root of. I know the square root of 9 is 3, and this should be enough to graph the square root function. We have 0, 0, 1, 1, 4, 2, and 9, 3. And so our square root graph looks like a sideways parabola, but only half of it is showing. Now what's the domain? Well, it goes to the left up to 0, and it goes to the right forever. The domain is a square bracket because it includes 0, and it goes to the right forever. Question 5. Determine the intervals of the domain over which the function is continuous. In order to be continuous, you cannot lift your pen off the graph as you continue on the curve. And that's continuous from 3 all the way to the right here. So it's continuous from 3 all the way to infinity. This is the domain in which it's continuous. In question 6, again, we want to determine where this is continuous. I know it's continuous from this point all the way up to this hole here. We have a hole at x equals 2. It's not continuous there, but it is continuous to the right of that. So we have continuity from negative infinity up to 2. So we'll use a parenthesis because it does not include a 2. And then we're going to include 2 to infinity, also the right side. This graph is continuous from negative infinity to 2, union 2 to infinity. Question 7, for the piecewise linear function, find f of negative 3, f of negative 1, f of 0, f of 2, and f of 4. We'll start with part A. What's f of negative 3? We know that negative 3 is less than or equal to negative 1, so we'll plug it into the first part of the function. We have 3 times negative 3 equals negative 9. F of negative 3 equals negative 9. For part B, we're looking for f of negative 1. Negative 1 is less than or equal to negative 1, so we're going to use the first category again. We'll use 3x for our function. We'll plug in a negative 1 for x. 3 times negative 1 equals negative 3. Part C, let's find f of 0. We know 0 is greater than negative 1, so we'll have to use this part of our piecewise function. We'll plug in a 0 into x minus 2, and this equals negative 2. f of 0 is equal to negative 2. For part D, we're looking for f of 2, and that's greater than negative 1. So again, we'll plug it into x minus 2. That's 2 minus 2. That gives me 0. For part E, since we're looking for f of 4, x is clearly greater than negative 1. We'll plug it into x minus 2 again. 4 minus 2 equals 2. F of 4 is equal to 2. We'll start by making a table. I want to look at all the values of x that are less than negative 4. And we'll plug it into the equation 2 plus 2x. Now, I'm going to pick negative 4, negative 5, and negative 6 and plug it into the x. Now, we said that we had to pick values of x that are less than negative 4. But why did I pick negative 4? Well, I know at negative 4, we're not going to include it as part of the graph. It's going to be an open circle at x equals negative 4 for this part of the graph. But we still need it to figure out where the open circle is. So just be aware this is going to be an open circle for this point. Now, I want you to plug in negative 4 into 2 plus 2x and figure out what you get. Then do it with negative 5 and then a negative 6. This should give you negative 6, negative 8, negative 10. So double check to make sure you get negative 6, negative 8, and negative 10. Now I'm going to look at the middle part of this piecewise function. I want to pick values of x that are between negative 4 and 5, and these are going to be included. So these will not be wholes. We'll use negative 4, 0, and 5, and I'm plugging it into negative 2x. Let's plug these values into negative 2x. We should get positive 8, 0, and negative 10. Now we will use next, let's look at the values of x that are greater than 5. Greater than 5. I'm still going to pick 5, but I have to be aware that at 5 it's not included. This is a greater symbol, so we want to make sure we use an open circle here at the point when x is equal to 5. We'll plug it into 3x, and let's use some more values. Let's say 6 and 7. Plugging the values into 3x, we should get 15, 18, and 21. Now we have all the points that we need. Let's start the graph. Let's graph these points on some graph paper. Again, be aware that the point negative 4, negative 6 will have an open circle, and the point 5, 15 will also have an open circle. We'll plot the point negative 4, negative 6, and recall this has to be an open circle. Then we'll plot negative 5, negative 8, negative 6, 10, negative 6, negative 10, that is. We'll plot the point negative 6, negative 10, and we can see that this should be a line going towards the downward direction. Then we'll plot negative 4, 8. This has to be a closed circle because it's included. The point 0, 0, and the point 5, negative 10. This should also represent a line. 5, 15 is an open circle because we had the value 5 was greater for 5 should be an open circle. We have 5, 15 should be an open circle. Then 6, 18. And this should also represent a line pointing this direction. This is our piecewise graph. We have a line with an open circle at -4 for the x, and then we have another line in the middle with both closed circles, and a line on the right with an open circle here at the end point. Question 9. Let's graph another piecewise function, f of x equals x cubed plus 4 if we have x between -2 and 0, x plus 4 if x is between 0 and 1, not including the endpoints, and 5 plus x minus x squared if x is between 1 and 3, including the endpoints. We'll start again with a table. For the first part of the graph, we want to pick values of x that are between -2 and 0, including 0, and including -2. I will pick -2, -1, and 0, and plug these values of x into x cubed plus 4. This should give you -4, +3, and +4. For the second part of the graph, let's plug in values that are between 0 and 1, but 0 and 1 are not included because this is a less than symbol. But we'll include it in our table. Just be aware those will be open circles for those points. We'll pick 0, we'll pick 0.5, and we'll pick 1. Again, be aware that at 0 it will be open and at 1 it will be open because we have less than symbols. 0 plus 4 is 4, 0.5 plus 4 is 4.5, and 1 plus 4 is 5. For the last part of the graph, we'll check values of x that are between 1 and 3. Let's pick 1, 2, 3. And since these are included in the graph, they're going to be closed circles. We'll have to plug it into 5 plus x minus x squared. If you plug in these values into our function, we have the first one should be a 5. The second one should be equivalent to 3. When you plug in 3 into 5 plus x minus x squared, you should get -1. So please double check these values and make sure they're correct. Since we have all the points now, let's go to our graph paper and do the problem on the graph. We'll plot the point -2, -4. This is a closed circle. We'll plot -1, 3, 0, 4. And so it looks like we have this curve here pointing downwards. And we'll plot the point 0, 4. Now 0, 4 was supposed to be an open circle, but it's filled in by the previous graph, so this is actually a closed circle. The previous part of the graph, x cubed plus 4, fills it in, so this is actually a closed circle. Now we'll plot the point 0.5, 4.5, and then 1, 5 is an open circle. Next we'll plot 1, 5, and that fills in the previous open circle. This is now closed. Next we'll plot 2, 3, and 3, -1. If you want a better graph, you can do more points, but this is good enough for us. Here is the graph of our piecewise function. Notice also it is continuous everywhere because all of the holes are filled in. Question 10. Give a rule of the piecewise defined function. Also give the domain and range. We'll start with the domain first. The domain is how far left the graph goes to how far right it goes. It goes to the left -infinity, and then it stops when x is equal to -1. We're going to put a comma, -1 with a square bracket because there's a closed circle here, and then there's a jump. We'll use union it jumps to a 2, but this is not included, it's an open circle. We'll use a parentheses 2, and it goes to the right forever. This is our domain, negative infinity to negative 1, including the negative 1, union 2 comma infinity. The range is how far down to how far up the graph goes. In this case, it's stuck at negative 1, and it's also stuck at 2. It doesn't go up or down from those values. The range would be negative 1 and 2. Notice I'm using curly brackets because it's just negative 1 and 2. There's no interval for the range. There's only two possible y values. You can only have a negative 1 or a 2 for the y values. For the last part, let's construct a function that defines this graph. We have a constant function of 2, and that's for x values that are less than or equal to negative 1. And then we have another constant function at negative 1. This is for x values that are strictly greater than 2. It's not included because we have an open circle. So this is our piecewise function. F of x is equal to the constant function 2 if x is less than or equal to negative 1. It's equal to the constant function negative 1 if x is greater than 2.